Hello everyone. In this video, I'm going to be talking about the basics of Lambda expressions in C++. So Lambda expressions were recently introduced. In fact, they were introduced in C++ 11. So after that, all the versions which come after 11, they have the ability to allow the programmer to write Lambda expressions. So Lambda expressions have now given us the ability to write inline functions. So inline functions are very similar to the arrow functions in JavaScript, as you may see in this slide. Uh, Basically, you don't have to specify the, the function keyword, that is when you're working in Java, and it's a bit similar as well in C++. Certain things are omitted if you compare it to the usual way in which functions are defined in C++. So they Lambda expressions have code which we will not reuse. Like when you want to sort an array in JavaScript, for example, each array will be unique. So the way you would sort, the way you would iterate through the array would be highly specific to that particular scenario. So you're not likely to reuse that code. And I believe that's what Lambda expressions allow us to do as well. So basically, this is the general syntax of a Lambda expression. The first section here is the header of the Lambda expression. Then you have the body, which is enclosed in the two open and closing curly brace, and then the header is a bit similar to the regular function which we have in C++, in the sense that you can specify the return type and you have a parameter list, but there's no function name. So we can also say that Lambda expressions allow us to write anonymous inline functions. So yeah, so the first part is the capture clause, then we have the parameter list, then we have the return type. And another thing that's worth noting is that just like we can assign a function to a variable in JavaScript, we can also do the same thing in C++ as well. We can assign a Lambda expression to a function, then we can assign a Lambda expression to a variable. We can then use the opening and closing brackets to invoke the function on the variable name. So we'll see how that happens in a minute. But I would like first of all to examine the components which make up the header of the Lambda expression. So the first part is the capture clause. So the capture clause, it specifies how we will be able to access external variables. So when you write your function, your anonymous function within the scope of another function or within a class, how must you access the variables outside that particular Lambda expression? So the capture clause specifies how that can be done. So there are mainly three methods in which we may be able to capture the external variables. So we may do that by reference, by value, or both, or in fact, none. So let's look at how we would do that by reference. So by reference, we simply indicate an ampersand within the square brackets, which is in the capture clause. So what that means is that you are going to access all other variables outside the scope of this particular Lambda expression, and you're going to access them by reference. In other words, the values which are placed in those variables outside will not have to be copied into the Lambda expression. However, you may just be able to access them by reference. So let's quickly look at an example of that. So if you want to write any code which has lambdas in C++, you have to enable C++ 11 and above. That's when it's going to work. Otherwise, it will not work. Okay, so let's take, for example, in my main function here, I've got a variable x, and it's assigned the value 9. Okay, and then let's have a variable here. We're going to call it print. Okay, then we're going to assign it to a lambda expression, and then this lambda expression will have a body, and we'll close it like that. So when we put an ampersand in the square brackets, what we're telling the compiler is this particular lambda expression will have access to this variable by reference. So when we do something like when we print it out, for example, what's going to happen is we will not be printing it out based on the value which was received. However, this x is, we received the reference to x. So in this case, there's no copying which is happening. You normally would want to use this technique when you're passing in objects into your lambda expression so that you don't waste memory. You want to pass by reference as opposed to passing by value. So that's one scenario in which you would use the ampersand, that is the capture clause reference. And the next one is passing by value. So to pass by value, you simply indicate an equal sign there. So when you indicate the equal sign here, so what that means is it's going to get the value of, for example, as we saw in here, it's going to get the value of x, and then with that value, it will then copy it into the body of this lambda expression. So by doing that, you have copied the data. So you normally want to do this when you are just dealing with primitive data. But for objects, please always pass by reference. And it must be noted that when, for example, you have another variable here, y, and this is 9.0, what this means is that, rather, when you have u, what this means is when you put an equal sign here in this nature, it's going to allow the contents of the lambda expression to access all other variables outside it by value. So all of them. It's not specifically one, but it's going to allow the contents to access all other functions outside. If we want to limit it to a specific variable which we want to access by value, we would just put x. So what that means is it's going to allow x to be accessed by the contents of the lambda expression by value, but u will not be able to be accessed within this body. In fact, if I tried to even use u at some point, let me just try to write a quick print statement and reference y, or rather u, you will notice that it's going to give us an error. So there's an error there. So this error simply means that we have not been given the access to u because we haven't explicitly specified that we want to use it. So that's how you would also specify what you want to use from the enclosing scope outside the lambda expression and what you do not want to use. So basically that's what passing by value means. And then you can use either or both of them. So in terms of using both of them, so in this case I would specify that I want to use the value of x by copying it into the body of this lambda expression. Alternatively, I could also say that I want to access u by reference. So what's that going to do is it's going to allow us to access x by value and u by reference. And so when we do something like print, okay, so when we print it out to the console, notice what's going to be printed out on the screen. So we will have the two values, which is 9 and 9. Okay, so the reason why the 0.0 isn't showing is because we did not configure the cout object to allow decimal places to be shown. But that's the point. So if for instance you would want to use either of the two or both of them, this is how you would do it. So if you have a couple of variables outside the lambda expression, you would explicitly state which ones are supposed to have, which ones you would want to access within the lambda expression, and that's how it would work out. Then we have nothing. So in the event that you do not specify the capture clause, and then you make an attempt to use x, for example, okay, you make an attempt to use x, perhaps in a cout statement, this will produce an error, because when you don't specify the capture clause, your lambda expression will not have access to the external variables within the enclosing scope. If you do not specify the capture clause, your lambda expression won't have access to the variables outside the enclosing scope. So always make sure that you specify. In the event that you want to use a value which is outside, decide on how you would want the lambda expression to use those variables. Is it by value, by reference, or you may also look at the this pointer and see how that would work out. So basically, that's how you would use the capture clauses. And then the next component in the lambda expression header is the parameter list. So all functions may or may not have a parameter list, but if they do have a parameter list, then arguments can be passed to that particular function by one of three ways. You may pass by reference, by value, or by pointer. So the first image here shows how we can pass arguments to a lambda expression by reference, because we have indicated the ampersand symbol right after the data type of the parameter. So in this case, the address which we send will be shared across the two scopes. So for instance, let's suppose I have y. Let's suppose I have y here, and then it has the value 78, and then I'm quickly going to print it out. I'm going to print out the address of y. So I'm going to say address of y. Okay. So when say address of y, then within the body of within the header of this lambda expression, I'm going to specify that you must receive an argument, and that argument should share the address. So when I try to print out the address of you, notice what's going to happen. So I'm going to send in y here. Okay, so here we've declared a variable y. It holds the value 78. We've printed out the address of y, and then we have created the lambda expression. Within the header, we specified the parameter which will receive a reference, and then we're printed out the reference within the body of the lambda expression, and then we simply invoke it like that. So when we run this program, we're supposed to expect to see the same address repeated, and that's what we see here. So this address and that address are the same, which indicates that we've successfully passed by reference. So you're able to pass by reference. Normally you'd want to use this, as I mentioned earlier on, when you're dealing with objects. You don't want to copy objects because they are very huge and they occupy a lot of memory. So, and then you can also pass by value, and this is the regular way in which we're used to passing data. So you can pass it by value like that, and so in this case you would expect to see 78 printed on the screen, and that's how it would be done. So it's going to print out 78, and just like that, that's how you'd pass by value. You can also pass by pointer, and so pointers also occupy some space. Like the last time I checked, it occupies 8 bytes on the machine which I ran on. So you may also want to pass the pointer by reference. Think of it that you have a certain loop which is invoking a function, and then with each invocation you are sending data. You're copying a pointer to that particular function. And if you run this over and over again, imagine you iterate 100 times, so it means you're going to have about 800 bytes reserved just for that iteration. So you'd also want to pass the pointer by reference by simply indicating the ampersand, and that's how you would do it. And then lastly is the return type. So the return type can or cannot be specified. The beauty with Lambda expressions is the compiler itself will infer the type at runtime, rather at compile time. So as the program is compiling, it will look at the type of the returned value, and then that is what is going to be considered as the return type for the entire Lambda expression. However, there are situations where you would want to state the return type. In that case, you would simply have to include the um, the the arrow notation, and then you indicate the return type. And then of course here would say return u, yeah, something like that. So it simply returns what is sent to it, and then in here we can say cout, and then can print out the value of y. So we've declared y, we've sent y to print, but it simply returns that back, and it's going to be printed out to the console as well. So that's how you would use a return statement, and that's how you'd explicitly indicate that you would want to return an integer from the Lambda expression.